13.3 Sum and difference of angle identities. So this lesson is all about how to use certain identities to find angles we normally can't. So for example, 105. If we draw out 105, this will give you an example. 0, here's 180. 105 is in here somewhere, it's 90. And if I subtract find a reference angle, 180 minus 75, I get 75. We don't have a 75-degree angle. It's not one of the ones we know. So we can't do this normally. The way we'd solve that is to use these sum and difference formulas. Now we'll give you these. You know how to memorize them. You have to know how to use them though. These I will provide you. Sum of a plus b is sine of a plus cosine b plus cosine a sine of b. Really, if you notice, sine switches the values. It's a mixture of sine and cosine. Same thing here. If it's a negative, negative. Cosine is a little different. It's cosine a cosine b minus sine a sine b. Right, so sine switches it but keeps the same sign. Cosine starts off with cosine but then switches the operation and then ends with sine. Same thing here, right? Cosine a minus b is cosines, then you switch it plus sine. So that's the key thing to know. Sine is just, again, I'll give you these, but sine has it mixed but then keeps the same operation. Cosine has it like the same cosine but then switches operation. And then tan is this one. A lot of times the way I find tan, I just do sine over cosine personally. But there's a formula for that also. And that's all this lesson is about. It's about how to use these formulas to find unusual angles that we're not used to. There's a couple tricks to this too. So let's talk about some of the tricks. So we're gonna have to break up to sine A and sine B. And the first trick is you always want one of them to be 45. It's always gonna work. One of these always has to be 45, so you want to make one of them be 45. This makes life easier. So you make one of these 45, and you be the other one, whatever it's going to be. Now sometimes 45 is going to be A, sometimes it's going to be B, sometimes it doesn't matter. Like when it's a plus, it doesn't really matter. But we always want one to be 45. So that's trick 1. Trick 2 is you want to convert to degrees. So one time we're going to convert to degrees. It's just a lot easier to break up to 45 if it's in degrees. If it's in radians, then power 4, it's just fractions and gets ugly. So convert to degrees is trick 2. Trick 3 is this. Now for all my team triangle people over here, team table does this already. If I give you a 45-degree angle, because remember we're going to break it up to 45 degrees, the sides are 1, 1, rad 2. And if I do sine or cosine of that, I'm going to get 1 over rad 2. Now, for this case, we actually want to rationalize it because it's going to make the math a lot easier. So from now on, I want you guys to know that if you do sine or cosine of 45, the answer is always going to be rad 2 over 2 every single time. So sine and cosine of 45 is always rad 2 over 2, right? Because if you do a 45-degree angle, it's 1, 1, rad 2, sine and cosine are the same. And if you rationalize, you get rad 2 over 2. So this is more of a some memorization thing. It's to make your life so much easier. Because we're going to use that all the time. Right? We're always going to use the 45. So this helps if you memorize sine of 45 and cosine of 45 is rad 2 over 2. And that's always true. No matter where you go, it's going to be rad 2 over 2. Sometimes it changes the signs. But if we use 45, it's always going to be rad 2 over 2. And those are the 3 tricks to make this easy. So let's do an example. See what we're talking about here. So let me erase this. And then we're going to do sine of 45. So first thing I'm going to do is use the formula to break it up. And that takes forever. That's an insufficient shading. Too inefficient. So we're going to break this up. Now you have 2 choices. You can break it up with the minus or you can break it with the plus. Again, notice it's sine. I use one of these 2. Now I like to use the plus when it's a chance. Whenever you have a chance. So let's do this. Sine. Remember, one of them, the easiest trick is make one of them 45. It's 45 plus. What plus 45 equals 105? 60. So sine of 40, right? 45 plus 60 equals 105. And then I actually know how to do 60, and I know how to do 45, so I just do it. If you want to do the minus one, you could do probably be like this, sine of minus 45. You just gotta think, what minus 45 gets me 105? So it'll be 150. That way it works also. I think this way is a little easier though. So let's use the formula. If I'm going to break this up, the formula says sine of A plus B is just sine of A, switch it, cosine of B, keep the same operation, then switch these. Sine of B, cosine of A. So we're just going to follow that. We're going to do sine of the first one, cosine of the second one, plus, switch it, sine of the second one, cosine of the first one. Now remember that third trick I told you? This is where we're going to use it, right? We purposely always make 45 because now I know these two. Sine of 45 is rad 2 over 2. Cosine of 45 is rad 2 over 2. All I got to do is find cosine of 60 and sine of 60. Now again, that you can do any way you want. Table, triangle, whatever wherever you want to do. So I'm going to do a triangle real quick because you know the way I roll. So this is 60. Opposite 60 is rad 3. Half honest is 2. Adjacent 1. Cosine is adjacent right hypotenuse, so 1/2. Sine, so, is opposite right hypotenuse, so rad 3 over 2. And then all we have to do is multiply these and add them up. So this times this is rad 2 over 4. Remember when you multiply across. Multiply across. So I get this, and I could add them up. Now remember when you add, you only add the tops when the bottoms match. So rad 2 plus rad 6 over 4. I can't add 2 and 6, right, because they're both different radicals, so you just leave it like that. And that's the idea. You break it up, always use the 45, and then once you put it into the formula, all it is simplifying each one and doing the math. That's literally it. So let's do a few more examples. The next one. Cosine of negative 15. So this one probably have to do a negative one. So let's break it up. Now remember, you always want to use 45 somewhere. So you got to think either like, let me add these two and see what I get, 30. Like try to figure out a way to do it. So let's do 30 minus 45. Right, 30 minus 45 is negative 15. And then I'm going to use the formula to break it up. The cosine formula is cosine of the first one, cosine of the second one, switch the operation, and then do sine. And right, again, third trick. Oh, cosine of 45, we know what that is. Rad 2 over 2. Sine of 45, we know what that is. All we gotta do is cosine 30, sine 30. I'm hoping by this case, if no matter which way you do it, you kind of get a little better at memorizing what sine 30 is, which is 1/2. And maybe you memorize cosine of 30. Rad 3 over 2. Right, again, I don't care how you do it. You want to do the table. 30 is right here. Sine will be 1/2. Cosine will be rad 3 over 2. If you do a triangle, 30 is small, it gets to 1. Hypotenuse is always 2, and this is rad 3. So the way you do it, you're going to get these values. Simplify, multiply those together. Rad 6 over 4 plus rad 2 over 4. I get rad 6 plus rad 2 over 4. Again, that's all it is to it. Break it up, and then do each one separately. Let's do a few more. I want to make one of these a radiant one so we can talk about that. Let's do like 7 pi over 4 here. I think 7 pi over 12 actually is what would be there. Anyways, do this one real quick. So I got to break it up. Again, same trick. When it's big like this, I just do like 45 plus. What plus 45 equals 160? 120. Use the formula, and remember cosine goes same. Switch the operation, and then sine. Right, so I'm just using the formula again. I will give you the formula, you just got to use it. And then the third trick, cosine of 70 45 is automatically rad 2 over 2. We know that one by heart. Same thing with sine. Now, if I want to find out what cosine of 120 is or sine of 120, luckily they're the same angle. I just got to draw it. 0, 120, 180, sorry. This is 90. 120 should be in here somewhere. And then you got to figure out the reference angle, which goes to the x. That should be 60. Again, I don't care how you do this, right? Table, triangle, whatever way you do it. Either way, you should know that it's a 1. That's supposed to be a 1. And a 2. That sine, cosine 120 is negative 1 over 2. Right, if you're doing a table, you look at the 60. Cosine 60 is 1 over 2. Don't forget to make sure if you're doing the right sign, positive or negative. All students take calculus. So in quadrant 2, my cosine should be negative, my sine should be positive. Sine of 120, opposite of hypotenuse, rad 3 over 2. Do a little mathematics, negative rad 2 over 4 minus rad 6 over 4, and I get negative rad 2 minus rad 6 over 4. If you notice, they're all pretty much the same answer, just like different signs, but that's kind of the way it is. Let's do one more of these, and then we'll move on to the next thing. Cosine of 75 over 12. So if I see this, I'm like, oh, radians, that sucks. Well, first thing you do is just convert it. Just make it into degrees. So we're going to multiply by, now remember, if you want to make it degrees, you multiply it to 180 in pi, but you want to get rid of the pi, so it's on the bottom. So you get like this. You get 7 times 180 over 12. You can reduce it. I can divide both of these by 6, and I get 2, and I get 30. I can divide it to more, I guess. 1 and 15. 15 times 7 is 105. So cosine of 75 over 12 is sending us cosine of 105. Now we just break it up. Cosine of 45, we always use 45, and 60. Right? Exact same process. The one difference, if they give you a radians, just convert it first. It's a lot easier to break it up in degrees. Then you just use the formula. Cosine 45, cosine 60, minus sine of 45, sine 60. We're pro now. Cosine 45 is rad 2 over 2. Sine 45 is the same thing. Cosine 60, think about it. What's cosine? Let's actually start with sine first. Sine's a little easier. I think sine's way easier. What's sine 60? Rad 3 over 2. Cosine 60? 1 over 2. If you're not sure, draw your table or make your triangle. And then you get rad 2 over 4 minus rad 6 over 4. Also known as rad 2 minus rad 6 over 4. Right? And that's the process. If you want to find trig of some weird angle, try using the separation. Try using the sum and difference formulas. I will give them to you. You know how to use them. You just plug them in. Same thing with tan. I go over tan with the exact same thing. I'm going to skip that one. So, I was doing this real application problem. And I was doing it, like I converted, plugged it in. I was doing math and I was supposed to use some different formula. But once you actually did it, I could do it by hand. Like I didn't need some different formulas. So I was like, what's the point? So I just kind of skipped over it. So we're going to skip over it. I mean, you can see what I did there. Just convert to minutes, plug it in, simplify, and then do the rest. Normal problem. Let's get to something new. Well, kind of new. So part 2 of this is we're going to combine the last 3 sections together. So we're going to verify and use some different inequalities. For the most part, it's not as bad as it seems because these are actually much more straightforward than the normal problems we've been doing. So all we're really going to do is use some different formulas and just kind of see what happens. Let's start with the first one. So I want this to match cosine. So first thing I notice is, hey, this is like a difference formula. So we're going to use the sine difference formula. Remember, I will give you these formulas, but it's good to have them kind of memorized. I mean, it helps. I'll give them to you. The sine one is you mix the sine and cosine, and then you keep the sign though, keep the operation. So it's sine of A, cosine B. Then since it's minus, I keep the minus, sine B, cosine A. So I'm going to do that here. I'm going to do sine 90, cosine theta, keep the sine, and then we switch it. Sine theta, cosine 90. Now when I'm trying to verify, remember when I'm trying to verify anything, I cannot work on this side. Well, I can't work on, you have to work on one side at a time. You can't add over or anything like that. So I'm working on this side first. So I get here. Now if you learn anything in trig, please learn this. You have to know the basic unit circle. Right? So when I say that, I mean like the key points. 0, 90, which is also known as pi over 2. 180, also known as pi. 270, also known as 3 pi over 2. And 360. If you know anything, you have to know this. So right here, we went to the right, 1, 0. We're going up, 0, 1. You can also do this on your table, but anyway you know, you have to know these. Negative 1, 0. And 0, negative 1. Sine E, cosine X. That's how I remember which one's which. So in this case, all we have to do is simplify this. Sine of 90, well here's 90. Sine's the Y value, So this is going to be 1 times cosine theta minus sine. Cosine 90, cosine's the x value. So this is going to be sine theta times 0. 0 times anything is 0. So this just goes away. I get cosine theta. And they match. Right? A lot more straightforward. You just use the formula. Hey, they match. Next one. Same idea. Now it's a cosine form we're going to use. So cosine 90, cosine theta, because remember cosine, it's the same at the beginning. It uses the opposite operation. And then we're going to do sine. Sine. It says sine. Cosine 90 like we did up there. Same value. Cosine is the x value, so that's 0. So this would be 0 times cosine theta. Sine 90, same thing we did up there. Sine of 90, sine is the y value, so 1. Remember, if you learn anything about trig, learn the unit circle, please. Sine of theta. This goes away, so 0 times anything is 0, and I get negative sine theta, which matches. Let's get a little more difficult. So tan of theta plus pi over 2 equals negative cotan. Now we haven't done a tan one yet, so I'm going to go look at the formulas to remind myself. Alright, so tan plus is tan A plus B over 1 minus tan A times tan B. So based on the formula, it's going to be tan theta plus tan pi over 2 all over 1 minus tan theta tan pi over 2. So right now, and actually that's not going to work. Tan of pi over 2 is undefined. Sine over cosine, tan sine over cosine. You're going to get 1 over 0. That's undefined. So actually it's not going to work. It was bugging me. Like that's not going to happen. So what we're going to do instead is this. Tan is the same thing as sine theta plus pi over 2 over cosine theta plus pi over 2. Right, so it's tan is sine over cosine, so I'm going to split it up, and I'm going to do each one of these separately. So, remember, sine is sine cosine, then you keep the sine operation. So sine theta, cosine pi over 2, keep the sine, sine pi over 2, cosine theta. On the bottom, cosine is cosine cosine, so cosine theta, cosine pi over 2. Switch the operation, then sine theta, sine pi over 2. Much like before, again, the key thing to know is all the basic ones. So pi over 2, 0, pi over 2. Again, I don't care if you do this like this or with the table. Up there you went up, so your y is 1, not your x. And then all we have to know is sine e cosine x, sine's the y value, cosine's the x value. So in this problem here, cosine pi over 2 is 0, sine pi over 2 is 1. So this side's going to go away, and I'm going to get 1 times cosine is cosine, over 1 times negative sine is negative sine. Cosine over sine, negative cotan. And they match. Alright, so that was a bit harder. We'll do about 2 more and then we're done. This one here, same idea, right? Oh, cosine, use the formula. So remember, it's cosine of the first, cosine of the second, switch the sign, sine of the first, sine of the second. We need 3 pi over 2. Here's 0, here's pi over 2, here's pi, here's 3 pi over 2. We're going down, so it's 0, negative 1, the y. Or you can do the table. Again, I don't care. Cosine is x, sine e, sine's y. So cosine 3 pi over 2 is just the x value. Cosine is x, that's 0. Sine 3 pi over 2 is the y value. This goes away, I get negative sine theta. One final one right here. Sine theta plus pi over 2. It's all the same idea, right? We just use the formula. The formula for sine is sine theta cosine pi. Switch it. Keep the sign. Sine pi. Cosine theta. 0, pi over 2, pi. Negative 1, 0. Again, we went to the left, so x is negative 1, or use a table, whatever. Sine, cosine's the x value, so negative 1. Sine's the y value, so 0. And look what happens. These cancel out to 0. Negative 1 times anything is still negative sign. And it's just plus. Negative sine theta. Boom, they match. So that's the whole idea, right? We're gonna use these formulas a lot. If I give you verifying identities, just distribute it and then simplify it. You have to know the units, right? It comes up so often. If you're gonna learn one thing about sine and cosines, how to do that. If they give you 10, you can do it two ways. You could use a 10 formula, which in this case I didn't work. So you got undefined. That was weird. So I had to break it up to sine over cosine. And if I give you numbers, just break it up to 45 and something else. It's always gonna work. Right? If they give you radians, convert it to degrees first and then break it up. Same thing here. I would break this one up to 45 plus negative 255. It will still work. It'll just be a little funky, but it still works. And that's the idea. Until next time.